Hi, I'm John Paulraj, and in this video we will continue to solve question number 2 from paper 3, May 2025, time zone 3 for IB Mathematics Applications and Interpretations. Let's go. George uses his model to predict the values of n at the end of the years 2017 to 2021. These values are shown in the following table, correct to one decimal place. So this is the predicted values according to the model. This was the model that we talked about in the earlier video. If you didn't see that, go and check out in the playlist. So basically he's collected the data, created the model using the data, and then these are the predicted values, okay, at the end of 2016, 2017. By the way, this is at the beginning of 2016, okay? So remember that's given in bold. Every time something is given in bold, make sure that you're paying attention. 2016, beginning of 2016 literally should be interpreted as at the end of 2015. All right, keep that in mind. We'll refer to that later on. So D, calculate the value of A. This is the predicted value for the end of 2019, right? Yeah, this is the end of the years, all right? So yeah, correct to one decimal place. So let's do that. This is T equals 4 and capital N is equal to 0.6. Okay, so where shall I do that? This is to A, B, C, 1 and 2. We did that, now to D. All right, so question 2D with the value of C and K we computed last time. All right, so let me just make sure that I get the formula, copy the formula correctly. This is what I meant even in the last video. Whenever I check, because there's always a possibility of copying error, even though you've got it down. Okay, capital N is 310. So we got capital N as 310. 1 plus C times, it's 1 plus C times e to the power of minus kt. Okay, let's just copy it down as it is, minus kt. Now let's put the values of C and K. So this is 310. 1 plus C was 2450. 2450 times e to the power of, that was K, as you can see, 0.45t, e to the power of a minus 0.458, and then you have the t. Okay, this is your n, the prediction. Okay, so we want for t equals, is it 4? Let me just check that again. 0, yeah, t is 4. Okay, so that's the value of A. So we can say that at t equals 4, substitute it. That's something that you got to show that. Okay, capital N is then 310, and remember these numbers, you know, even though it's coming as decimals, it's in millions, don't forget that. Okay, so 1 plus 2450 e to the power of a minus 0.458 times 4. Mention this you need to show to the examiner, then you can say using GDC. Okay, the value of n is. So let's just jump back to our calculator. Maybe it would have been a good idea to just, so what we'll do is that first we will just clear this off, and we will define the n as a function. We may need to use it, you know, in some of the context. So n, remember, it's in terms of t, so just say n of t. Okay, and we will define it with this one. This symbol is colon and equal to, and then we'll just put that template for the division sign, and then just copy down the expression as it is. Okay, just be careful. 310, the numerator, and the denominator we have 1 plus and 2450. I'm just going to copy this entire term, okay, and paste it here. And I've done this several times in the past. You know from my earlier videos, if you watched my earlier videos, it just helps to preserve accuracy. See, all the digits are there except for, instead of just taking 2450, preserves accuracy, times e to the power of, this is the thing for e to the power of with a negative, and in place of k, again, I'm going to take as many digits as possible to preserve accuracy. Because otherwise, you know, what we've written, that 0.458 is just rounded off to 3SF, right? Okay, and I hope I get this thing right. There you go. And then here we can put t. Okay, so we've defined in terms of t, n of t, and when you say, it'll say done. Okay, now we want to find at t equals 4, so we can just say n at 4, and you just hit Control Enter. It'll round off as 0.7, and let's just check the digits again if it's rounded off correctly. 0.789. Okay, to 3SF should be 0.790. Okay, so that's a good thing, and I can just come back to my calculate and say, okay, this is 0.790, but I think they wanted to 1 decimal place. Let me just check that. Okay, this is a good habit. Okay, just check. Yeah, calculate. Can you see? Calculate the value of a correct to 1 decimal place. So we'll go back and change that 0.790 as, you can say this is 0.8 1 decimal place. And if you want here, you can say 3SF. Okay, that's good. That's good. So they know that you've rounded off to 1 decimal place. That's the value of a. Okay, so this is a is 0.81 decimal place. So that a is the value of n when t equals 4. That's how you should interpret it. Cool. So this is 2 part D. Am I right? D. Okay, let's move to E now. What does it say? Using the value of a correct to 1 decimal place that we just found out, find the sum of square residuals when this model using this model to predict the values of n. So we want to find the value of the sum of the square residuals. Residuals is the predicted value minus the actual value, okay, and the squares of that. So basically, I'll just write it down here, okay, if that's all right. This is 2e, right? So 2e is basically what SSRE is, right? This is basically 0.3 minus 0.3, okay, square of that, okay. Sum of the squares, sum is this, okay, so then 0.5 minus 0.4 square of that, okay. So I'm just taking the predicted values minus the actual values, all right, plus the value of a we got was 0.8, right, 0.8 minus 0.6 square of that, and 1.2 minus 1.1 square of that, plus 2.0 minus 1.9. This part you must show. The substitution part you must show, okay, and then of course you can jump to the calculator. So this is, I didn't want to scroll down, you know, there was space, so I wrote it there, okay. So let's just jump to the calculator quickly and see how we can do this part. And okay, so it does take time to enter. This is just 0. I don't know why am I even entering this. Okay, square plus 0.5 minus 0.4 square plus what do I have, 0.8 minus 0.6 square of that, and plus 1.2 minus 1.1 and bracket square of that, and the last term 2.0 minus 1.9, and don't forget you're looking for the square of that. Okay, control enter, and it is 0.07. Check the 3SF rounding. Oh, to 0.07. So I'm just going to write this thing down here as 0.07. Got it? Okay. As a measure of how well the model fits the data, George uses the error function e, where e is equal to the under root of what we just found out, right? The sum of the square residuals over n. N is how many values here? 1, 2, 3, 4, 5. N is 5. Okay, square root of that term, and n is the number of predictions made using the model. There you go. These are the 5 values, right? We've predicted using the model. And then George decides he will use this model if that error function is less than 0.25. So by finding the value of e for George's model, show that George will decide to use the model. Show that George will decide that the model can be used. Okay, so basically we need to find out and show that e is less than 0.25 for this value of SSRS that we got. Let me just do it here to the side. This is 2f, right? So 2f is, the error function is under root of SS over n, and we've just found that value as 0.7. N is 5, square root of that. Am I right? Yeah. And this again you can write down using GDC. Every time you use the phrase, you write it down, okay, using GDC. And there you go. You can come here and you can get rid of this term now and say control. Oh, you want this one, right? There you go. No, it should have been the other way around. Sorry. Let's get the square root sign first, and then we can get the template. That'll become easier. 0.7. It's 0.07. Huh? I was just commenting about this. Can you see this? Sometimes when you're even looking at the same number, I made this mistake a couple of times. Just copying down something. Wow. And I commented about the silly errors thing, I think in the last video. Okay. I'm making a number of silly errors. I think I need to make a video on why these things happen. This happens to everybody. It's not just, if you're a student who's watching this, it's probably just not you. It happens to everyone. As I said in the last video, maybe what we can do is just find ways how to minimize these kind of errors by just checking constantly. Did you copy it down correctly? Did you copy it down correctly? Okay. That's the only way to go ahead and do this thing. All right, let me just jump back again. Just wanted to show, and you probably know by now, I'm not editing these mistakes. It's just possible. It's possible for anybody, okay, to make such kind of errors. Okay, 0.118. 118, that's corrected to 3 SF. So I'm just going to come back and say that this is 0.118, and this is definitely less than the value that they're saying, right? 0.25, and therefore we have to conclude, right? Show that George will be, so therefore George can use the model. Okay, that model N. All right, G. All right. Use the model to predict the number of EVs in the European Union at the end of 2035. All right, so that's 2 marks. Use the model to predict the number of. So this is the model. Remember, the model is this formula, and we've already entered. That was the beauty. We've already entered the or defined it as a function, right? So at the end of 2035, we just need to figure out what is that value of t. Remember, I said this is the end of 2015, right? So beginning of 2016 means end of 2015, and they're looking for the number at the end of 2000. That phrase is important. The end of 2035. So end of 2015, end of 2035. It's like 20 years. So t is equal to 25. We can just use that, right? T is equal to 25 because we've already stored it in the calculator. We already put it in the calculator. So 2G, question 2G. Did I copy that down? I'm always checking because I know how many errors I make. 2G, yeah. 2G, we can just say that's the value, right? Again, we can say using GDC, t is equal to 20 for end of 2035. So capital N, you'll probably need to copy down the whole thing again. This one, this expression, you have to just copy down. Even though you're using the calculator, make sure you copy down, except that t, where we wrote 4 here, you have to write 20 this time. So 310 over 1 plus 2450 e to the power of a minus 0.0458, and here times 20. Okay, this part we need to show. Now, we've already said using GDC, you can jump to the calculator, and this is where I said it is really good that we've defined it. Okay, so we can go now and just say n of 20. Okay, and hit Control Enter. Remember, this value is in millions, 247. All right, so this is to 3SF, right? 247 millions is what I'm going to write down. Okay, so here we can say 247 millions. This is basically quite a large number. Okay, at the end of 2035, that 247 million is a really large number of electric vehicles by the end of 2035. Well, this video has gone a little long, but we will try and complete this particular question in the next video. If you found this video useful, please make sure that you like, you share this video with a friend, and subscribe to my channel. If you visit my channel, there are plenty other videos on my channel. Do check them out. And if you want any question, if you have any doubt, if you want any topic explained, do mention that in the comments and I'll make a video for you.